All right, so chapter 1, section 4 is measure and classifying angles. So we're going to learn what an angle is, how to name it, how to find the measure of it, all sorts of stuff like that. So we start with the definition. An angle is formed by two rays that have the same endpoint. The rays are the sides of the angles. And the common endpoint is called the vertex. All right, so when we name an angle, there's the option of doing 3 letters. So no matter what angle you're looking at, you can use 3 letters to name it. So in this example, and it goes in order from the side to the vertex of the side. But the order of the sides doesn't matter as long as the vertex is in the middle. So if I was going to name this angle, I can call this angle PNO or angle ONP. If there is only one angle formed with that vertex, I can also use one letter like this, okay? So I can also call this angle N. That would change if I added on a point here like Q. Now if I asked you to tell me which one was angle N, how would you know which one I was referring to, right? There's more than one option. So if your vertex is shared by more than one angle, then you must use the 3 letters, okay? If there's only one, then you can use the 1 letter. But if it's shared by more than one angle, then you have to use all 3 letters, okay? Now notice that they said that the sides are rays, okay? And notice the notation on here. So that ray NP and ray NO are the sides of your angles. Some of you on the quiz, when it asked to give me an opposite ray, did not put the symbol over above it. If you just write NP, you're saying line segment NP, okay? You need the little arrow over the top of it to show that it's a ray, or you need the word ray, NP, in front of it. Yeah. It's really important how we note things on, because you have to learn the differentiation, and it's going to come into play every time you read an instruction or something like that. If I say NP without the symbol on top, I'm talking about a segment. If I say ray NP, it's got to have the little arrow over it, okay? And the arrow has to go over the letter in which the arrow points. So in this case, the N's got the end point, and the P has the arrow. Okay. Questions on any of that? So the sides of an angle are rays, and the vertex is a point. Okay, so we just talked about naming an angle when it's shared. So if this is shared, technically there's at least 3 angles here that I can identify, right? Go ahead and see if you can name them. So who can give me one name of an angle? Angle ABC, okay, which also has the name what? What's the same name of that same angle? CBA, okay, so that's talking about the same angle. Whether it's ABC or CBA, it's the same angle. What's another angle, Emily? ABD, which can also be called DBA. And the last one, Madison, DBC, which can also be called CBD. Okay, so there are 3 angles there. The top one, the bottom one, and the one of them combined. And again, on an example like that, you would not be able to say B, right? Because you wouldn't know which angle I was talking about. Questions? Okay, measuring an angle. So if I'm actually measuring an angle to get a measurement, I would use what's called a protractor. So a protractor is the tool used to measure an angle. Angles are measured in degrees. And there are 4 ways to classify an angle by its measure. The first is if it falls between 0 and 90, it's acute, like a cute little angle, okay? If it's exactly 90 degrees, straight up and down, then it's a right angle. It equals 90 degrees. And it will have that little box in it. If it's between 90 and 180, it's considered to be obtuse. And straight, which would be a line, okay, or 2 opposite rays, would equal 180 degrees. Okay, so this one says, draw an angle, label it with your initials, and then we're going to measure it. So make it any size you want. Make it acute, make it obtuse, make it right, whatever you want. Go ahead and draw yourself an angle. And label it with your initials. If you don't have a middle name, just make something up. Okay, so I'm going to drag it so that the corner matches up. And then I'm going to see as close as I can where it crosses through. So mine appears to be about 45 degrees. Okay, yours will be whatever it is. If you don't have an angle that's flat on the bottom like mine is, like say it's turned this way, okay, then in Notability you can't rotate the protractor, okay, but in EduCreations you can. In Explain Everything, I'm almost, that might make a lie out of me, but in Explain Everything you can, okay, so Notability is the only place, really, not the only place, but it's not as easy to drag it and rotate it, okay, so if you have a protractor at home, you can use it. If you want to use the ones here, you can use it. If not, then you can use it that way. Very rarely are you going to be measuring. It might be a couple of questions in tonight's homework, and then that's about it. But just so you can get an idea of how to measure. Okay. So now if I were to classify this, okay, what type of angle is my acute? Okay. Yours might be different. But anything less than 90 degrees, most people tend to draw an acute one, which is interesting. Some of us draw obtuse, and good for you. Be different. Okay? But you want to just be able to classify it. If it's less than 90, it's acute. In between 90 and 180, it's obtuse. Right at 90, it's a right angle, and then straight line, which I doubt any of you drew, but if you did, it would be 180 degrees to be straight. Pretty enough. When you see this line cross through, I moved my protractor, but when it was directly on it, yeah, I moved it. You're welcome. But when it was directly on it, it runs through. And notice that there's two numbers there. This is where you've got to apply what you know about acute and obtuse to your protractor, okay? If my angle was here, I would know that that's obtuse and I need to use the larger of the two angles, right? The larger of the two measurements. If it's over here where it was, it's acute, I know I need to use the smaller of the two. Questions? Okay. All right, so this is the protractor postulate, which just says, consider that OB, which is line OB, and a point A on one side of line OB, the rays of the form of the ray OA can be matched 1-to-1 with the real numbers from 0 to 180. So if you remember, the ruler postulate just said that if I have a coordinate, if I have a line, I can give it a coordinate, which is a number. This is kind of the same thing, but applying it to an angle. If I have an angle, I can give it a measure. That's all this says. Okay, no matter what the angle is, I can give it a measure that's a real number. Okay, so non-imaginary. All right, and then we had segment addition postulate. Now we have angle addition postulate. So segment said if I took a segment, broke it down into its parts, I should be able to add it to get back the whole. Same exact thing for angle addition postulate, except now we're talking about angles. So if B is in the interior of AOC, so if I've got a point somewhere on the inside of the angle, then AOB plus BOC equals AOC. So I'm going to zoom in on this picture real fast. Okay, I've got an angle drawn there. Let's say I started with AOC. B has to be interior. Interior means in between the two rays. So B could be anywhere in this space. Okay? If B is in that space, then I can make another angle. I actually can split it into two angles by adding that ray. So all this says is if whatever this big measurement was, I would get by adding the smaller two. So angle AOC plus, okay, congruent angles are angles with equal measure. So equal is referring to the measure, and the angles themselves are said to be congruent. So if I knew they both were 30 degrees, they'd be equal, but the angles themselves are said to be congruent. And again, congruent has this little symbol on the top. It's a little wave over the equal sign. And congruency marks. Okay, so you're gonna start to see congruency marks on segments, you're going to start to see congruency marks on angles, and then we've also added in the right angle one. So these two little marks tell you that segment AE is congruent to segment ED. This little arc and this little arc tells you that angle AEB is congruent to angle BEC. And then this little angle here tells you that angle CED is a right angle. Okay, we had a segment bisector, now we're talking about an angle bisector. So a bisector of an angle is a ray, has to be a ray, that divides the angle into two congruent angles. So it cuts the big angle into two equal parts, and it cuts its measure in half. So in this little diagram, ray BD, which is this right here, is the angle bisector of ABC. So it'll either be written that way, or it will say ABD bisects angle ABC. Or you'll see the measures, like this is 20 and this is 20, so I know it's bisected by ray BD. Or you'll see congruency marks, like this, and then you would know that that's the bisector. Or you'll see a statement like this that says angle ABD is equal to DBC. So that's 5 different ways that you can determine that something is a bisector. Either literally the words, this is the angle bisector, or this bisects the angle, or the two are equal, or based on a diagram. You'll have the measures of the two, or you'll have the congruency marks. Any of those 5 ways would tell you that ray BD is the bisector of the angle. Okay, so this one just says give another name for each angle. I'm actually going to give you a little bit of time to work on this, and then we'll go over it. So for each one that's listed there, you want to use the diagram that's there to give another name. It could be other letters. It could be a number, okay? There's only one angle that I can name with one letter. Can you tell me which one it is?
C.
Angle C. Everybody see that? That's the only angle there that I can name with one letter, because it's the only one that doesn't have a shear vertex. All right, so angle DEB is this angle here. You can give me another name for it. DEB. Wait, that's the one that they give you. BED. Anybody else use something different? How about angle 4? Is that the same angle? Yep. If we wanted to be really nitpicky, how about angle CEB? Is that the same angle? Those are rays, right? So I can stop it at the D, or I can go past it, right? So I could have said CEB works as well. Does that make sense? Yeah, everybody sees that? Okay. Okay, angle CBE, so CBE is here. So I could have said EBC, or I could say what? Angle 8. Okay, BEA would be here. So again, switch to AEB, or I could call this what? Angle 3. Okay, DAB. I could say BAD. I could say angle 1. I could say what? CAD. Or DAC. Okay, same thing. No. Okay, just going to stick with that one. All right, so angle 7 could also be called what? Angle ECA, angle ACE, angle BCE, angle ECB, okay? Those are all the same thing, and we said that this is the one that was special because it didn't have a shared vertex. It could just be called C. Questions on that one? Yep. Leah? Could it be DCB? Sure. Hunter, was that your question too? Yeah, okay. Could it be DCB? Yep, and BCD for that matter, right? Okay. Angle 9 is here. Okay, angle EBA, angle ABE. Okay, can I determine that angle 9 is a right angle?
Yes.
Trick question. No, it appears to be a right angle, right? It looks like it's a right angle. It has to have that little box. Either has to have that little box or it has to say somewhere angle EBA is 90 degrees, okay? So you can never determine it from a picture. The only thing you can determine from a picture about an angle is if it's straight. So angle ABC is the straight line, which means that that's 180. So that's the only measurement you can get from a picture without some sort of marking, okay? Does that make sense? All right. Okay, so then angle 1 plus angle 2. So we're saying add this angle to this angle, which forms this big angle here, which would be angle EAB, angle EAC, or BAE, or CAE. Any of that works, okay? So I want to add those two together to get the whole. So it's the segment addition postulate. I'm sorry, angle addition postulate. Angle 3 and 4. So if I add this one and this one, I get angle AEC, good. Or CEA. Fernando.
Can you just put angle E?
No, because E could be for angle 3 or angle 4 or the big one. So if it's got a shared vertex, you can't use it. Good question though. All right, and 5 and 6. 5 and 6. So what does 5 and 6 add up to give you? Angle EDC, angle CDA. What else do we know about angle 5 plus 6? It would be a straight line, which would tell you what about its measure? 180. So if this little measure angle here wasn't here, I could say the measure of angle 5 plus the measure of angle 6 would equal 180 degrees. Okay, so that's the only one on that whole diagram, like only those straight lines, can you determine what the actual measure would be. Questions? Okay.